In this video, we're going to take a look at how to handle correlation problems using Excel. So if you watch the calculator video, this one is identical to the calculator video. It's the same problem that we're looking at. So essentially our data set shows the percentage of third grade students proficient in reading and math in 10 states, and these turn out to be the 10 most populous states. So in California, for example, 60% of students are proficient in reading, 59% are proficient in math. And as you go through, these are your ordered pairs. So for each state, that's one ordered pair. Our goal is to compute the correlation coefficient, compute the least squares regression line, and then ultimately use the least squares regression line to predict math proficiency in New Mexico, which is a state we don't have data for, given that the reading proficiency in New Mexico is 65%. So we're going to try to use our least squares regression line to make a prediction. I'm going to come over here now to the Excel sheet. I've already loaded and copied this exact same data set right here. And I'm going to maximize the screen here so it's a little bit easier to see what I'm doing. So if we want to find some of these values, there's a couple of things we can do. One of them is if we want to start with that part A that said find the correlation coefficient. The correlation coefficient, if I can type, which is our value of R, maybe I want to compute that down here. Oh, that's funny. Turn that into a, don't need to trademark it. So the let's just call it R. So the correlation coefficient R, I can find by typing in a formula. And the formula that I will do, so we start off with the equal sign, so it knows we're going to start typing in a formula, and I'm going to start typing in correlation. And you'll see it says autocomplete once I've got the two R's, correlation, C-O-R-R-E-L, that's the correlation command. And then it asks for us to put in our two arrays. The first array is my X array, so I can enter that by just highlighting, dragging and highlighting the first set of numbers, or I could manually type B2, which is the starting entry here, down to B11, which is the ending point. So there's my first set of data, and I'll put a comma in and then do my second set of data. Then we'll close our parentheses, hit enter, and we get 0.808623 ... If we round this to 3 decimals, we'd get 0.809. So there's my correlation coefficient. To get the least squares regression line, we're going to actually enter or create a scatter plot in Excel. And there will actually be a second way we can get this correlation coefficient if you don't want to do this approach here. So for the second approach, what I'm going to do is come up to the top and go to Insert. And this is where I want to insert. Once you click on Insert, it'll bring up a whole bunch of options. I want to come over here to where it shows all the charts. And you can see right down here, there's something that looks like a scatter plot. So if I click on this, it'll have a bunch of options. This is the first, the main option I want to do. So I just need to highlight the set of data. So start by highlighting the data that we want to use. Then come over here to the chart and hover over scatter plot and click on it. And it'll generate a scatter plot. This scatter plot looks kind of awful because the origin is way down here at 0, 0, and all the data was up in the 50s, 60s, 70s, and so on, so it's way far away. If we want to clean it up a little bit, we can double click on the axes down here, and it'll bring up this Format Axis option on the right side. We can change how it looks. It gives us some options for like shadowing stuff, for shifting stuff around. But this last one over here is the one that I want to use. It has the bounds on this axis, so we clicked on the x-axis, and I know that the smallest value of x was this 60 here, so as long as I enter a number smaller than that for my minimum bound, I'm going to enter 50. And I'm going to only have it plot, instead of from 0 all the way up to 90, I'm going to have it just plot from 50 up to 90 so that we zoom in a little bit more. So if I do that and click enter, it changes the graph and it's a little bit better. But I still have all this blank area down here. So I'm going to do the same thing with the y-axis. If I double click on the y-axis, Sure enough, you'll see that it's set to having a minimum value of 0 over here, but in reality, the smallest value of the y's was 59. So I'm going to do 50 for my lowest bound. Anything less than 59 would be fine, but I'm going to do 50 again and hit enter again. And now I have a much better looking chart. This isn't necessary, but if you were wanting to do this on the exam to help you draw something, this would be a good thing that you could do and then sort of copy from there. The most important thing that we need to do, though, is to get the least squares regression line. What I want to do is just click on the chart here and then come up over here to where it says add a chart element. So I'm under the, if you get lost, we're under the chart design option. And notice if I click somewhere else off of the chart, if I click anywhere else, that chart design option disappears. But if I click on the chart, I'll have this option that says chart design. And I want to click on chart design and now come over here to where it says add chart element. If I click on this, I can scroll down to where it says trend line. This is where we want to fit the trend line to our data. So we want, in this case, a linear trend line. So that's what I want. You can see hovering over it, it draws it in place. So there is our least squares regression line drawn into place. But I want some more options on that. So if I come down back to trend line, and I come down to this bottom option that says more trend line options and click on that, what it'll bring up is all these trend line options over here. And again, there's a bunch of stuff you can make the line be a solid line instead of a dotted line. If I do that and I click enter and so on and so forth, I don't really care about that. What I want to do is come over to, again, this little bar graph option where it has some more trend line options. So not over here where it's changing what it looks like, but come to the little bar graph, click on that, and go down and notice it'll have a couple of options down near the bottom that we're interested in. One of them is display the equation on the chart. I want it to display the equation. And as soon as I click that, you'll notice the equation popped up here. Let me move it up here so it's a little easier to see. And then similarly, coming back over here, oops, I want to click on the whole chart. Let's click on the trend line. So another option is you can literally just click on the trend line instead of having to come back up here. So if you just click on the trend line, come back over to the graph, go down. I also want it to display the r squared value, and it will draw that number right there. So this is another way that we can find the value of r that we're doing over here. This is r squared. If I wanted to back out what r was from this formula, I would just take this number and take the square root of that number. And we could do that wherever we want. So I could just copy that number down here with a square root function. I believe if I type square root, it will sqrt. I think that is the command for square root. Let's see in a minute if I'm right or wrong. And then I want to type in that number. So 0.6539 and hit enter. Nope, that did not do it. Oops, I forgot my equal sign. Now hit enter. There we go. So this is another way to get the value of r. You'll notice it lines up pretty closely. It's off a little bit because this number here was rounded. So we can either find r using the correlation function, or once we have the value of r squared, which our scatter plot can spit out for us, I can simply copy that number and take the square root of it. But you've got to remember, again, it's a formula, so you've got to do equals square root of copy that number, and it'll give us another estimate of the value of r. So here are two values that we can use for our estimation of the value of r. And here is our least squares regression line. And if we minimize this, or not minimize it, but make it a little bit smaller, I now have the information I need to answer these questions over here. So for example, if we wanted to compute the correlation coefficient, we've just found that. I'm going to type it in. It's going to be a little messy. So this r value was about 0.809 if we round it. The least squares regression line, that's sitting right up here. So let me just move the little chart down here. So there's our least squares regression line. Just keep in mind that we want to use a y. Sorry, my handwriting is going to be bad because my screen isn't in tablet mode here. I apologize. So y with a hat on it is equal to, and we can copy down the equation of the line right here. So about 0.8226x plus 11.036. So I've been able to answer both of these two questions here using the commands in Excel. So again, this is the information that we need. Now that I have all of this information, I'm going to go back to my drawing over here. I'm going to maximize that so we can answer now the last part. So let me zoom in and we can answer part C based on the answers we just found in Excel. So to predict the math proficiency in New Mexico, if we know that the reading proficiency here is 65%, I just need to plug into this formula. We remember that y in this case represents the math scores, and x represents the reading scores. So if I plug in a reading score, this thing will spit out its prediction for the corresponding math score. And that's what we're going to do. So I will write this as y hat equals 0.8226 times x, but the x value that we're using is right here. It's our 65%. So I'm going to plug that in times 65 and then add the 11.036. And if you do this on a calculator, you should get about 64.5 roughly. And I'll write that as a percent. So our best guess for math proficiency is about 64.5% based on the fact that reading proficiency was 65. All we're doing is using the least squares regression line to make a prediction on an incomplete data set. In New Mexico, if we only have half the data, we plug that half in, the x value that we know, and it'll spit out the y value that we are looking for, or at least our best possible guess. So that is how we can use Excel to solve problems involving correlation.